do more area. So, review, right triangle here. So, we have our A, B, and C. Right triangle, Pythagorean theorem. So 8 squared plus 4 squared equals C squared. Okay, so this is 16 plus 64. So C squared equals 80. I'm going to take the square root of both sides. And that tells me that C is approximately 8.94. Which makes sense. It is the longest side and it is bigger than 8. Number 2, we have a 45 and a 45-90 triangle. Remember, that means our magic number is radical 2. There's 2 different numbers, 45 and 90. I can remember it. We're trying to find one of the legs. So remember, when we're going from the hypotenuse to the leg, we're getting smaller. So we're going to divide by that radical 2. So 15 over radical 2. Now, if you're going to put a decimal answer, you can just divide this right now and get 10.6. Okay? If it asks you for an exact answer, and remember, exact means leave it with a radical, we need to rationalize it and get rid of that radical 2. Okay? Which is going to give us 15 radical 2 over 2. So either one of these answers is correct, depending on what you're asked to do. This is an exact answer, and this is a decimal approximation, rounded. Okay, not a 45, 45, 90. We only have one side, so we can't do Pythagoras, and it's not a 30, 60, 90. It's close with 32, but it's not 30. So we need to bring in our trigonometry. So here's our angle. From this angle, we do not have the opposite side. We have the adjacent side, and we have the hypotenuse. So AH is cosine, adjacent over hypotenuse. So we're going to do the cosine of 32 is 4.6 over x. Remember, we're going to switch the x with the cosine. Shortcut. When we type that in our calculator, you'll get 5.42. Again, that makes sense. The hypotenuse, it should be bigger than 4.6. Okay, determine these are always true, sometimes true, or never true. These are the abbreviations I'll use. Isosceles triangles are similar. Okay? That's sometimes true. Okay? I can have the same measurements, but with different angles. So I could have 2 legs on 2 different triangles be equal, but have different angles, which makes it not similar. The sum of lengths of 2 sides of the triangle is greater than the length of the third side. That's a rule. Okay? That is how triangles work. Any 2 sides must add up to more than the third side. Otherwise, you cannot actually make a triangle. A square is a rhombus. Okay? That's always true. Is a rhombus always a square? No. It's a one-directional always. Rhombus is sometimes a square, but not always. A rhombus has 4 equal sides. A square has 4 equal sides, so it's always true. 4. Opposite sides of a kite are parallel. Never true. That was supposed to be an N, but there we go. Never true. Okay? Kite is not a parallelogram. Diagonals of a parallelogram bisect each other. That is a property of a parallelogram. An equilateral polygon is regular. That is sometimes true. And let me give you an example of that. This is going to be a horrible drawing. It's going to be a worse drawing when it does that. So I'm going to draw a really bad hexagon. Actually, that's not too bad. That's pretty darn good. Okay, so there's a hexagon, right? It's regular. All the sides are equal. All these angles are perfectly matching. You can see that, how well drawn that is. Now, if I take that same and that's going to be worse just because it has to be. Not bad. And these are all equal, but then this side comes in like that. It has kind of a warped Pac-Man look. Okay? Those angles are different in that one. All around, not matching. So therefore, even though all the sides are equal, so equilateral, it is not regular. Okay, new stuff. Area of a rhombus or a kite. Two things we just talked about. Well, we don't really talk about length and width here. We have distance 1 and distance 2. So the formula is 1/2 d1 times d2. Kind of like with a triangle, 1/2 base times height. But these are distances from corner to corner. All right. So quite simple here. We are going to just take, let's just make that into a big A. Haha, outsmarted you, board. 1/2 8 times 6. Do it in your head. You can do 6 times 8 and divide by 2, or half of 8 is 4 times 6, 24. Doesn't matter. And it's meters squared because it's area. Over here, area is 1/2 10 times 7. Half of 10 is 5, times 7 is 35. Not too challenging. Okay, now, a little bit more involved here. We have ABCDE, a pentagon inside a circle, inscribed in F. Find each angle measure. Okay, AFB. Okay, so that's this angle right here. AFB. Now, that is, if you think about it, a central angle. And that's key. Okay? That's a central angle. Now, what we have here is a circle with 1, 2, 3, 4, 5 central angles. And what do we have here? Basically a circle. So we're dividing that 360 degrees of the circle 5 ways. And that gives us 72 degrees. So AFB is 72 degrees. Okay? Now, AFG, where's that? Well, that's right here. Okay? Now, we're going to get into this today. FG bisects AFB. Okay? So therefore, we just divide our answer from A by 2, and we get 36 degrees. Now, this is leading into where we're going today, GAF. Where's GAF? Well, GAF is right here. This angle right here. Well, using the concept of a triangle, we know this is 90, and we just said this is 36. So how do we find this? 180 minus 90 minus 36. And that gives us 54 degrees. All right, so the new stuff. If we have a regular polygon, like that pentagon that we just drew was, and remember, a regular polygon has all equal sides and all equal angles. So the formula is 1/2 this little special line right here, called the apothem, or apothem, depending on how you pronounce it, all right, times the perimeter. Okay? So, let's get into this. We have a regular nonagon. Nonagon means 9-sided. Okay? With a radius of 4. So, what I'm going to do here is I'm going to take this triangle out and just do this part right here. So, here we have L, here we have K, and here we have M. Now we have a 90-degree angle here. This is 4. Okay? So, what we're going to do now is use trigonometry, as we just reviewed, to find this part right here. Now, we need the central angle. Well, remember, we just talked about if we divide up 360 divided by 9, that's 40 degrees. So this central angle is 40 degrees. Well, if you just did the previous problem, that makes this bisected 20 degrees. All right? Now, we could find angle K, but that doesn't really matter with what we're going to do because we're trying to find the side here. So, we're going to use trigonometry, and we're going to say the sine of 20 degrees. Now, we're trying to find the opposite, and we have the hypotenuse. Well, that's sine, opposite over hypotenuse. So sine of 20 is the opposite over the hypotenuse. So all we're going to do is type in our calculator 4 times sine of 20 and get 1.37. Now, that's just this piece right here, 1.37. So we have 1.37 here, but don't forget, this is half of that triangle right here. I don't know why I just wrote 2. Well, I do actually. Because we're going to multiply this by 2, which is going to give us 2.74. Now, that is, 2.74 is this length right here. Now, remember, for this formula that we just learned, area is 1/2 A, which we do know, not know yet, and P, which we can figure out. How? Well, we know this is 2.74, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9 of those. So if I take this times 9, I get 24.66. And that's my perimeter. That's very important. So you might want to circle that. That's a very key piece of information. Now we also need to find this piece right here. Well, again, we can use trigonometry. So we use a sine to find x. We're going to use a cosine to find y. So I'm saying cosine, again, of 20 equals, remember, cosine is adjacent over hypotenuse. So that's y over, what's hypotenuse? Again, 4. So very simply, y is equal to 4 times the cosine of 20, which is 3.76. That's also very important because that's my apothem. So now, the area is 1/2, 3.76 times 24.66. And that gives me 46.36 units squared. That's my area. A lot of work, but just step by step. Very simple calculations. Just got to work through it slowly. Okay, similar concept here. First thing we need to do is draw our triangle. Our central angle triangle. Alright? And remember, we're going to actually cut this in half. And I'm going to redraw it. So I have my triangle here. And if I don't know what this is, I take 360 divided by 1, 2, 3, 4, 5, 6, 7, 8. So 360 divided by 8. Actually, hold on for a second here. I can actually do this one a little simpler. So let's do that. 19.6. We know this is 7.5 and 7.5. So instead of doing a trig, we don't need to because we can use the Pythagorean theorem to find our apothem. And we already can figure out our perimeter, 15 times 8, so let's save time. We could do trigonometry, okay, do 360 divided by 8, cut it in 2, find this. But we don't need to do that because we already have two sides of our triangle. So let's just do 7.5 squared plus b squared equals our hypotenuse squared. What we end up with is b squared equals 327.91. square root both of those, and B, which is my apothem, is 18.12. Alright? Now, real quickly, what's my perimeter? I need that. And remember, this is my apothem, so that's important. It's my apothem. My perimeter is 15 times 8, which is 120. So that's important also. Now I'm ready to go. Ready to finish this bad boy up. The area of this regular polygon, octagon, is 1/2 18.12 times 120. Half of 120 is 60, times 18.12 is 1,086.5 and then inches squared. And that's our area. That's it.